You still there, Ravi?
Yes, Ken, I'm back.
Yeah, I
How
tend to lose connection. It's not a very stable internet connection here.
in the hotel?
Yeah.
I see Gary now.
Hi,
Yes, that's
Gary.
usually my situation with an unstable internet.
I'm okay so far. So tell me if we have to do anything. Does Randy have his own presentation he'll share from his screen? Is he going to share from his screen?
I'll wait and see. Let's see.
I just sent him an email a few minutes ago about getting on and telling him that he should be prepared to show his slides. Ken, are you able to stay on for a while or maybe the whole thing?
Oh, I'm staying on. The problem is the instability of this connection. That's all.
Yeah, I understand. There's nothing you can do about that, or
Hmm.
little you can do about it anyway.
So I'll be here the whole time. I'll be on.
Okay.
And I made you the co-host. Ravi, you're a co-host. So they took us on a lab tour here. And one of the places we went had a setup kind of like, I don't know if you've ever seen the movie Tron. Is this working?
Tron goes way back. I remember seeing it a long time ago, and there's been an update since then, right?
Yeah. And so we put on these virtual reality glasses and something for your hands and feet as well. And then you ended up looking like you were a figure in Tron with these lights
Okay.
on your, and then, you ended up going, through all these
I,
alien
I guess I'd
landscapes and
rather
things.
be experiencing that than being in the environment of a war.
Yeah. No, this is just virtual reality.
Well,
Thing.
war at a distance seems like a virtual reality also. Unfortunately, it's
Yeah.
a real reality. I'm
So let's see.
going to check to see if I got
Did he,
anything back
he
from
he
Randy
sent me
about when he'll
slides?
join.
Randy didn't send me slides.
Okay, well, Randy, date and time.
Let me
Dear
check
Gary,
my
I am
email.
waiting and ready. Do you have any specific protocol for testing a connection so I can just sign in and do a slide share when the time comes?
You can test
Um,
it now. Request him
You,
to test it now.
yeah,
I don't see him here.
I had sent him the, yes, I'm just going to write him back with the link.
Saying we don't see you on the Zoom.
When you get in, we can test your slide presentations, and we should have 5 or 10 minutes for that. Okay, I'm just going to
But
send this back quickly.
I was going to request that he test it now.
Yes, that's the idea. I send him the link and it's saying we have 5 or 10 minutes now.
Oh, before we start, yeah.
Yeah, so we should be live streaming now and recording. Yeah, it says YouTube.
Does anybody have his presentation?
Ken said he didn't get it. I didn't get anything, but
I didn't get anything, so
by the way, you could put for next week, you can put on the main site before rather than just the week or the day. You can put on Pascal Hitzler's title. That way, people go to the overall Ontology Summit for 2026. They can see what's coming up as a
oh
title,
yeah, I'll
right?
have to do that. Yeah,
Yeah.
let me do that.
When do you get a chance?
Oh,
Knowing Ken, he is multitasking. So he might do it now.
Well, yes. I don't know about you, but I've gotten older. I have much more difficulty multitasking.
I'm a
Uh,
single track.
when people are speaking and there's something going on, like something on a TV or something's going on elsewhere in my environment, I have difficulty doing both.
Yes, yes, likewise.
And that's why when like I was presenting last week, I really wasn't able to monitor the chat at all.
Of course. Of course.
well, that's not.
Yeah.
I'll be monitoring the chat as much as I can.
By the way, I
Um,
think while we're waiting for him, I think it would be nice if some of us um, would continue some of the conversation we have in a particular meeting, like there was one on ontologies versus world models or knowledge bases that got mentioned, but we didn't have enough time to discuss it. And also, for me, it took me more time to sort of research a little bit about the topic than I had presented, but I thought it would be still interesting to put it on the forum. And the other thing is, if we have things coming up, we could advertise the topic coming up, like interoperability could be mentioned as an upcoming topic or whatever. Foundations is the next one. So foundations would be a good one to talk about and get people aware of from the forum.
Yes. Welcome.
Our speaker. Wonderful.
Welcome, our speaker, Randy. Thank you.
Welcome, Randy. Good to see you. I'm Gary. We've been communicating without imagery.
And
I'm glad you could do this. Ken is the overall
You
organizer
are
of the
muted.
summits, and
I
Ravi
am
is part of
muted.
the
There I
committee.
go.
Yeah, thank you. I'm Ravi.
Hello, Ravi.
Yeah. So what we want to do here, besides just getting to know each other, is test out your ability to display what you want to display.
Yep.
So I think Ken would be in the process of making you a co-host,
Okay.
co-lead on this, and then we could see how the displays look. Okay.
Okay. I am just looking for.
In the center, there
The
is a
share.
share.
Have
Yeah,
you had?
I've
Yeah.
got the share
Yeah.
noted. Let's see. It's each version of Zoom, it updates so frequently. I have to make sure I get the right screen. Let me see.
Well, you're in good company. We have many people that seem to be technically astute, but still have problems.
Oh yeah, it's every day is a new experience. I'm online in different time zones almost every day, sharing, and each experience is incredible to see the. Just wait, I'm going to. One can never test too much.
That's a
Now,
good sub-theme for our presentation. Yes.
what I'm going to do is there. There we go. Let's see. Now you should be able to see.
Yes, we see all the slides,
Multiple
the
slides.
slide deck.
And if you see
Yeah.
this,
There
I
we
can
go.
see that.
okay, that's good. So then I can go to the title slide and present that. That's the title slide.
Okay, anybody else have any comments on it? I can see it works for me.
Pretty good. Very clear. Very nicely done.
That looks like it'll work. One of the things that I note in the online presentations that makes remote presentations a little less comfortable is the management of the screens and the interaction. So when I can see hosts like the three of you that are signed on, I see you in a screen. Don't necessarily always see an audience depending on how you capture the online audience from your point of view. But it's never as comfortable as talking in person.
Yes. But we have saved so much travel from Alberta, from Phoenix, from
It's true.
Sacramento and East Coast. So,
Well, I noticed that Ravi's palm trees are wavering in the breeze, but Ken's are quiet. So it must be, it's less windy where Ken is.
well, actually, mine is a fake background. I'm sitting in Sacramento where there is no ocean. The nearest lake is Tahoe or the Bay Area.
Ken,
Aha.
you're in
Oh, wow.
Arizona now?
I'm in Arizona, and
Yeah,
that's just a photo of when I was in Maui.
This is
right.
that's looking outside my window at my condominium at the Edmonton River Valley, where the snow is melting and the trees will begin showing those things called leaves again soon, I hope.
Oh,
How
I'll
far are
be
you
in,
from the Rockies?
About 300 kilometers,
I see. Thank you.
which is just an afternoon drive from the Western Canadian perspective, of course.
I'll
Yeah.
be in Canmore in a month or so.
Oh, okay, yes. Canmore near Banff is a nice place.
Yeah, it's right in the Rockies.
Yep.
Wow.
Well, I'm
Um,
in Potomac, Maryland, near Washington, D.C., hoping not to get bombed today.
Ugh,
Yeah, I, I,
yeah.
I sort of sympathize. I don't know what words and mindset make sense to take anymore to be able to understand any of this. It's um, just there's no words, right? I don't have a way of creating a rational perspective on this. It's hard to deal with.
Yeah, to some, chaos is the point, I'm
Yeah,
afraid.
yes, I think that's right.
welcome, Janet.
And it's here.
Marsha is here.
Right.
It'll be,
Just as
Yes.
context, Randy, have you been able to see, have you had time or interest in looking at any of the prior presentations this year or any other
I
year?
looked at a few and I looked at your summary. I looked at the website.
Great.
I find a lot of natural alignment in the sense that remember I've been doing this for a long time too, and it's always a puzzle to me when I give talks at conferences when I hear what I think of as maybe a third generation for me, third generation of PhDs and PhD students, losing sight of the fact that knowledge makes a difference. Drives me crazy.
Yeah.
All our whole society is built on how we can incrementally build the scaffolding with knowledge created and retained for future generations. And some of my colleagues think the right way to pursue the science of intelligence is to rebuild it from scratch. It doesn't make so.
Well, of course, that's interesting, but that's not the only way.
Yeah, absolutely. Yes.
Well, among other things, I'd be just very happy to hear some of your historical perspective to, the overall very brief title is
Yep.
Yesterday, Today, and Tomorrow, because we're celebrating the 20th. So you and I go back a ways on symbolic
Yes.
AI, and I know that at least in some of your presentation, you ground this in some of the earlier thinking,
Yes,
like Turing and
absolutely.
so forth. I think that's all interesting.
Well, I don't. I think I teach we have one of the stronger undergraduate programs in Canada, and I have been conscripted because of my outspokenness of formal methods to teach the core course in discrete mathematics for computer scientists. And so, every term I'm talking about the foundations of Gödel and Turing and all of the things that matter because they're fundamental. You can't ignore them. They don't go away. You can't engineer your way around the halting problem.
Right. Yeah.
And just keeping that in perspective is a useful thing for modern students of AI.
I agree. By the way, we'll start soon, I think.
Okay.
Michael Gruninger may be on. He's been a
There he
large
is. He's
part
here.
of our.
Hello.
Hello.
Hey, Randy.
Hello.
Good to see you again.
Yeah.
Nice to see
Okay.
you
I was
too,
going to
Nick.
say
I
you
haven't
went
seen
to
you for a while.
Alberta as an undergraduate.
Yeah, yeah. I am where I am today because of Randy.
Yeah, so I know Michael from several places. I keep trying to think about some of them. Maybe University of Toronto, Waterloo, Alberta. There's all kinds of connections across that time frame.
Well, it's time we started, I think. We have,
Well,
so let me make the formal beginning of this, okay? So welcome everyone to Ontology Summit 2026. Today is March 11th, 2026. And we are thrilled to have Randy Goebel as our speaker. And the host of our meeting today will be Gary Bergcross. So I will now hand it over to Gary to begin our meeting. Go ahead,
Okay, well,
Gary.
thank you very much, Ken. And I'm very happy to host. This is our second session on our track, AI and Ontologies. And I'm very happy to have a very distinguished speaker today, Randy Goebel, who's a professor of computing science at University of Alberta and a co-founder of the Alberta Machine Intelligence Institute at that university. He's also the co-founder of Open Mind, which is a nonprofit incorporated open access research institute located in Canada and Singapore. I don't know if we'll have time to talk more about that, but that is, I think, of interest to many. He has had faculty appointments and visiting faculty appointments in many institutions, including the University of Waterloo, University of Regina, University of Tokyo, and Hokkaido in Sapporo, Japan. More detail on this is online as part of his bio. His research interests include formal knowledge representation and reasoning, like induction, belief revision, explainable AI. He's also interested in knowledge visualization, algorithmic complexity, natural language processing, systems bio, which got touched on briefly as part of our historical review of ontologies. And he's interested in applications in clinical medicine, legal reasoning, and automated driving. His talk today is entitled A Partial, in parenthesis, Framework for Debugging Foundation Models. And with that, let me turn it over to Randy.
Okay, thanks very much for the introduction, Gary, and thanks for the invitation. As I said a little earlier, I'm already feeling like I'm in a comfortable enclave because in looking at the background of the Ontology Summit and how it's evolved and the kinds of minds that it's attracted to interaction, already make me feel comfortable. Like I haven't walked into the lion's den. You all know that the Alberta Machine Intelligence Institute, for example, is one of the 3 federally funded AI institutes in Canada that I helped start 25 years ago, but it's also known as one of what I described to my reinforcement learning colleagues as one of the churches of reinforcement learning, of which I'm not necessarily a disciple. And the reason I say that is because in the case of transformer architectures to build deep neural networks for LLMs, attention is all you need. In the case of reinforcement learning, reward is all you need. And my position, as you will see very clearly, I think, is that knowledge is all you'll need. And some blend of these is important. The the role of the computer scientist that I take is that all of the systems that we design as experiments and attempt to build and then engineer to create value for humans um, are computer programs. And if when we lose track of the fact that these are computer programs, we lose track of some of the fundamentals of computing science, which is um, in what sense are programs debuggable? And that's part of what I want to focus on today in a quite broad scope tour of a bunch of things. I'll say a bit about OpenMind at the end. OpenMind is the result of Google buying DeepMind and closing down the second largest DeepMind office on the planet, which was in Edmonton. And so Rich Sutton and I started OpenMind as a not-for-profit research institute, not PI led, but led by a 12 or 10 or 12-year long agenda for AI, fundamental AI research that will be open and freely distributed. So we've raised enough money to start. We have about 10 people on staff being paid to do and follow that. I'll say a little bit more about that. And you'll note in what I speak, where I speak, you'll note some of the applications of the areas that Gary has already mentioned. So I'll just go on from there. Here's an outline of what I intend to talk about is, as I said, the motivation for me is as a computer scientist, AI systems, if you think of them as buggy computer programs, the question is, how are their architectures structured and to what degree should we need to understand how to debug them? And that will be sort of the focus of things. There is this fundamental question when you think about the spectrum of so-called neurosymbolic foundation models. There are not just two. They're not just symbols and deep neural networks recorded as statistical relationships amongst tokens. There are more than that, and I'll try to shed some light on that spectrum and what I've learned from other colleagues around the world. The question, should foundation models be debuggable, is maybe the most interesting one. And I have to say that I'm the opposite of the Dunning-Kruger effect, is that the more I study, the less confident I am that I know about whether they should be debuggable or not, but you'll see why. And then I'll say a little bit about how to put a sample of 4 different foundation models together in some ways to see that maybe that's an approach to a comprehensive view of building a science of intelligence. One of the things that I spend a lot of time doing is looking for instances of errors that LLMs make. This isn't a hard thing to do, to find instances of errors. But when I talk to a less technically informed audience, less technically informed than this audience, certainly, what I try to do is dispel the Eliza effect for people thinking that these computer programs are somehow conscious or useful as correspondence and interactions as sort of the level of a human, by asking humans to note errors. And so I've got 2 errors I want to show you, which motivates the question about whether such things should be debuggable. That on the left is a screenshot of the LLMs I have on my smartphone, and I use this to say as a counter to people who say, well, Randy, since we have all of these LLMs now on your smartphone, you can retire. You don't need to do your research anymore. And my response is that I've just finally learned enough to be able to make a contribution, so I'm not quitting now. So anyway, here's an example. So this one is relatively old. This is from relatively old in the current speed of things from last year. And the interesting thing is that the 2 examples that I have reveal my heritage as a kid from a Saskatchewan farming town. So if you ask Cloud, this is from Sonnet 3.7, what I know is when the small town I was in, it's about 5,000, and that's counting dogs and chickens as far as I can recall, is when the criteria for this as a small town in Saskatchewan becoming a city that is achieving city status. And the output from Claude when I asked what is the criteria for a city in Saskatchewan is these 2: minimum population, once a community achieves city status, it achieves it even if it drops below the 5,000. So if my dog and my chicken coop got emptied out by a fox, that's it. It stays. And this that I noted in red was not read in cloud. It was just another part of the text. It's wrong. It says it's worth noting that before 2005, the population requirement was higher. This is absolutely wrong. And as I mispasted on the right, I also asked Gemini about this, and you can see, oops, you can see there in my town officially became a city on August 1st, 1960. Its current population is 4,493 by a census in Wikipedia by 221. So there's some discrepancy. The only interesting part about this is that when we ask these kinds of so-called foundation models these questions, it's only us and our experience that provides us with the basis for understanding whether the outputs are correct or not. I don't have a slide on this. I have from several other talks. That is a slide of the of what I call the version of LLMs that produces abstractions like the word visualization clouds. But when you think of them that way, it becomes a little bit easier. The second example is one that's a lot more subtle and has to do with why the current foundation models created by transformers don't understand natural language except by mimicking it, thinking back to the old Chinese room, the philosopher's challenge of does the person in the Chinese room know Chinese or not? So think about this, is in my province, I played AA baseball, semi-professional baseball in a league that included a team that came from these two small towns you see in the map. Springside population 525, Theodore population 315. It's not very many people to choose a baseball team from. And so the Springside and Theodore towns combined to create a AA baseball team called the Springside Theodore Combines. And I played against the Springside Theodore Combines on a team from Melville, Saskatchewan. This isn't the kind of combine they were talking about. So this is a modern implement for fields that some of you will be familiar with. And the interesting thing is that a combine can be many things. That's not a surprise. The world is filled with synonyms, and it's the structure of language that causes the most grief when we try to use the subtleties or infer subtleties from the language use of LLMs. But here's another way of identifying an error. So in this case, I'm using a more recent version of an LLM, this case Gemini, asking it about the Springside Theater Combines, a simple prompt search. And of course, Gemini pipes up with saying what you can see there in a rural farming community refers to multiple combine harvesters working together during the critical harvest season. Perfectly plausible, right? Perfectly plausible inference one might attribute to a well-read person looking at all of the data available online about these two tiny Saskatchewan rural communities. The interesting thing is why it doesn't identify the Springside Theater Combines as a baseball team might be argued to be that there's no data available. That is, there is nothing online ingestible by modern LLMs that would allow it to resolve a potential ambiguity of Springside Theater Combines. And instead of making up the idea there that's perfectly plausible, multiple combine harvesters working together during the critical harvest season, which is plausible and in fact correct in some ways, the reality is that this data exists. Here is an example of a baseball tournament that documents the Springside Theater Combines losing to Steenan 4-1. And so that's just a snippet from this. You'll notice that Melville also lost to Steenan, so maybe they had a good team there. The point being, of course, is that this data is available a web crawler could find it, and it would at least introduce the idea that there's an alternative meaning for the Springside Theater Combines. And now the question is that the question that this begs, I think, is whether or not this is a bug, and if it is a bug, or if it's an unanticipated feature, what can we do to be able to provide some explanation of why one wouldn't get a description of the Springside Theater Combines as a baseball team in this part of the world, with the evidence, for example, is the thing I pasted from the Yorkton tournament labeled there. So two examples in boringly crucial, boring detail, I think, about what I think makes sense. Now, I'm going to put this in the context. Gary talked about history. I'll put this in the context of how I can use another kind of very simple architectural paradigm to understand how we could use computer programs, and you'll see in a minute, across a spectrum of foundation models, and use that paradigm to be able to refine the questions about what foundation models are and whether they should be debuggable. And I call this the query, update, explain paradigm, or the Q paradigm, only because I want to make it simple to recall. And so the Q paradigm is not unfamiliar to all of you, and to anybody who's read even just a few of the few papers in the long history, relatively speaking, the 50 to 60 year history of modern publications in AI. And so I take it this to be the paradigm, and a caricature of it is a human, and this is not unfamiliar to us thinking about Turing, asking questions and providing inputs to some computer program, expects back answers and explanations. So, of course, being able to ask questions and get answers is an important part of the paradigm. Explanations about answers is an important part of the paradigm, justifying an answer to a question. But the part that McCarthy spoke about in the 1950s was that you should be able to give a computer program inputs, and those inputs should adjust what the computer program records, and it should change what the answer to subsequent questions were if they're relevant. And so this is taken from 1958, the text, and the text is amplified here. The advantage that McCarthy said and gave to us about this paper published in 1958 is that this computer program will be able to improve its behavior by merely making statements to it. Now, you'll see in subsequent discussions this morning that the update problem, that is, of providing new information, however we provide it, you'll see a variety of ways, is an important, and it's the tricky bit. How do we update foundation models? And that will give you some idea about where I'm taking this. And there's another 10-hour lecture underneath all of this, of course. But let's go on from this, that example. So they're the two motivating, they're the two what I would call the motivating foundations of what I want to do. I'm going to say a little bit, these are just, again, Gemini, Wikipedia, and then this final one from the sort of the landmark paper with 100 or so authors from the creation of the Center for Research on Foundation Models at Stanford. Feifei Li and others have done this. I'm not a big fan of that because not that it didn't underscore some interesting aspects, because it declared what a foundation model was. And as a scientist, I don't like one group declaring something without evidence. But anyway, you'll see what foundation models are. And the errors that I spoke about and the query, update, explanation paradigm are the two things that motivate that. Oops, sorry, here I have to. This is a slide taken from Martin Chupa that talks about the possibility of there being more than one kind of foundation model. And in this case, he notes statistics and machine learning-based statistics for neural networks, large language model vectors. Remember that large language models with transformer architecture created deep neural networks are not the same kind of learning as informed learning, or if you like reinforcement learning with reward, and then symbolic representations, knowledge representation and rules. So that's just to give you some picture of that. Here's my picture that I'll use for the rest of this talk. And the picture speculates on this spectrum from logic to neural networks and tries to look at instances of foundation models along the way and what their status is with respect to the query, update, explanation paradigm, and whether and how each of them can be debugged. And so some of us are more familiar with the foundation models to the left of this, some more familiar with those to the right of this, but I want to largely use this as a framework for talking about different kinds of foundation models and discuss what I've observed about the properties of their debugging, or at least their updates, and then hopefully have time to get your input on how to think about this in more detail. One of the things that is interesting about this is that along that spectrum, you can draw what Dan Kahneman talked about, the spectrum of system one, system two thinking, thinking fast and thinking slow. Kahneman was a UBC professor in psychology when I was a PhD student there, so I knew him pretty well. And he used to come to our AI meetings at UBC. So we're familiar with how he thought about AI, but he hadn't formulated and written this book at this point. But it aligns with this description of foundation models. So another colleague from Catholic University in Belgium, Luc de Rat, formulated something similar to this, where he said thinking slow is reasoning and thinking fast. The current main paradigm in AI, he describes it as, has probability and logic on one end of the spectrum and deep neural networks on the other end. The reason that that's interesting because you want to distinguish places where the thinking fast is useful and the thinking slow is useful. One of my colleagues, Holger Huss, in RWTH in Germany, said that we should remind people that we wouldn't have modern computers if we didn't have AI, because the foundations of theorem provers for checking the designs of integrated circuits comes from work on artificial intelligence, which you can think of as slow thinking or theorem proving. Thinking fast is interesting, and I use this analogy. I got this one from the French philosopher Jean-Paul Sartre, but people will have known about the philosophical question, the tagger under the table. So in the thinking fast paradigm, you come home from work and you see this thing under your table that looks like a tagger, and you have to make a quick decision, an informed decision about preserving your life or ignoring this. And if you preserve your life by taking the utility action of getting out of your kitchen, because that tagger might be hungry, escape from the local zoo, and will eat you. It might be that it's your dog in a Halloween costume. You don't know for sure, but thinking quickly says use the utility of the situation to make a decision. Whether it's factual or not is less important than whether you have high utility. And you can think about all of those problems at that end of the spectrum in that way. So back to this neural symbolic framework, that means that thinking fast and thinking slow is at least something to think about across that spectrum. So that's the start of Randy's of the partial in parenthesis in the title, the partial framework for debugging large or debugging foundation models, most of which are at this end of the spectrum. So think about it that way. Now, here's an analogy that I've been using in the last 2 or 3 months at some talks I've been giving around the planet. If I think of LLMs built as transformers as the pandas of the machine learning world, as I've quoted here. So the pandas, certain species of sloth, I think the Brazilian sloth is one of those candidates, and even the Australian marsupials, the koalas, are in a similar category. That is, they consume an enormous amount, but have such an inefficient metabolism that they get very little nutritional value out of what they consume. So I think put LLMs on the right hand of that spectrum in that way. You've heard people say that we're running out of data to train our LLMs. Just think of them as pandas, is that they consume an enormous amount and get very little value out of it, unlike humans, for example, when we read things. And so I want you to use that analogy and think about it that way. Now, what you see in the spectrum is those things I previously noted as LLMs are almost exclusively built on models at the right end, at that end of the spectrum, that is at the spectrum noted here, towards the thinking fast area. You'll also note that almost all of the remediation of errors in the large language models is done by what are sometimes called reinforcement learning with human factors. That is, humans giving feedback on grossly misleading errors that come from those thinking fast transformer-based models, to be able to put them and constrain them in a way that reduces the number of errors. Excuse me. I'm pretty sure that Anthropic and ChatGPT and OpenAI are not wasting a lot of time trying to resolve the error of the Springside Theater combines. Nonetheless, the way that
What is the
debugging happens.
history?
Sorry? Somebody had a question.
Probably somebody's mic was open.
Oops, sorry.
Kindly continue.
Oh, I see more people now. Sorry.
Randy, we have lost your presentation.
Yeah, I went to look at the list of participants. I'm back.
We needed to cover more screen.
So let me go on from the spectrum, noting where the current large language models are situated in that foundation model, and now spend a little more time with the query update explanation paradigm to say how we deal with debugging each of those foundation models. So what I'm going to do is I'm going to put a subscript X on QUE just to have a way of summarizing in a notational form the debugging methods for the variety of X's, logic, probability, reinforcement learning, and deep neural networks as 4 examples of foundation models. And the punchline for most of you will be easy to see, be easy to anticipate, and to make a prediction about. In fact, if you used the slides as input to an LLM, they would already be able to make this prediction. And the prediction will be about how to combine those 4 foundation models and retain some of our ability to continue to interact with some amalgamation of them in the query, update, and explanation facility. So there's the labels that I'll use for each of these, and that will largely get us to the end. So the first thing to think about is that the debugging model for the end of the spectrum that uses symbolic logic as the representation of knowledge, the debugging methods largely boil down to what Elcheron, Gardenforth, and Mackison belief revision. Is if we know A and A implies B, and we're told that B is no longer true, we have a choice. We have to update and decide what it is we still believe. The computer scientist has an advantage here because these guys as logicians, I've met all 3 of them. Elcheron has passed on. I still know the other 2. The logician tends to want to get back to a consistent state of the world globally. computer scientist actually doesn't care so much, is we don't mind maintaining multiple self-consistent sets of data and then choose which provides us with the most important and relevant reasoning streams. But AGM belief revision is the debugging model that you can think about. If you think about what the probability model is, now I'm not talking about statistics, I'm talking about the propagation of the probability of an event given the probability of related events, the probability of A given probability of B. We already know how to propagate those answers. When we give an update and I tell you that the probability of Tweety flying is lower if Tweety is a penguin, we use Bayes' rule, and it works. It's a foundational method for debugging in the sense of changing the probability predictions based on priors when we adjust the probabilities of priors. So we have that as a debugging method. It's not a surprise that we have debugging methods for reinforcement learning policy. So Andy Barto and Rich Sutton have made a career out of that action you see there, of taking a learned policy, the one I have on the left, actions 1 through N, which is learned by some reward return history that gives you a ranking, a Markov decision process for at any instant in time saying which action is the one you should most likely take next to maximize your reward. And debugging says, oh, I have to be able to, if I want to make a change, that is, maybe the return on an action is such that action 3 now becomes the most plausible action and action 1 is demoted. That's what debugging comprises in the reinforcement learning as a foundation model. And remember that the informed nature of the reinforcement learning models are all about the calculation of return based on the reward received from a world and interacting with that world. So that kind of supervised learning. So that's the third part. Now the hard part. There are debugging methods for those 3 foundation aspects. The last one is backpropagation. So if you take the position that the foundation models at the right end of the spectrum are these incredibly complex, both in scale and in structure, incredibly complex statistical relationships recorded by transformer models, referred to as deep neural networks. The way that they're debugged, the way that deep neural networks have always been debugged is using backpropagation from this paper in 1986 by these 3, all 3 of which are still alive as far as I know. And of course, I know Jeff Hinton well because of the proximity between Toronto and Waterloo for so many years. So backpropagation is the debugging method for changing the outcome, that is for changing the output in the query update explanation paradigm, for changing the result of a question when you get a new update. So if I tell you that Tweety is a bird and ask if it flies and you say yes, regardless of your foundation model, then you're likely to change, and you would hope one would change if you say Tweety is a penguin, and then you know penguins don't fly. Backpropagation is what will help us, that will rescue us from the deep neural network representation, but it's not guaranteed to produce that output. So along this spectrum, what we get, and now here's something a little more technical. So non-monotonic reasoning and the use of belief revision gives us this kind of condition. So it says if we have these kinds of formal statements, the learning that Tweety is a penguin requires what the people on the right end of the spectrum might call a loss function, adjustment to a logical representation. And the adjustment is conditional that says birds fly, but penguins don't. So therefore, you can now conclude that Tweety doesn't fly in the context of that knowledge at the left end of the spectrum. What happens at the next end of the spectrum? Well, here, if we have declared by some method. Maybe we do it by statistical sampling of the event space that say 80% of the things we've seen that are birds fly. And so we conclude Tweety flies with the Bayes rule probability calculated on the priors that gives us 8. Then the loss function, once we declare that Tweety is a bird, we would expect somehow that the debugging using this, using however we provide that input would result in this condition that says the probability of Tweety flying is at least much less than 80%. That doesn't mean we get the same kind of categorical declaration that we did in the logical foundation model, the thinking slower model, if you want. But the intuition is, I think, compatible with us as humans. And there is an intuition to be exposed using Bayes' rule, so we can explain it. In this case, I've already shown you the diagram from Bartow and Sutton. In this case, choosing an action from a reinforcement learning policy, the explanation is an interesting thing. If you change the policy, so if action A1 is no longer at the head of the list in the policy you're learning, maybe you're doing continual learning on a stream of actions taken and rewards returned, at any one time, if you choose to change A1 to another action, then you need an explanation that has to be given in terms of relevant reward return used to learn the Markov decision policy. So notice that going from the left side of the spectrum to the right end, the vocabulary that you use for producing the updates and the explanations changes. In the case of probability-based foundations, you're making declarations, changing declarations on priors and hoping that Bayes' rule provides an explanation of why the predictive new probability of Tweety flying goes down. In the case of reinforcement learning, if you change what action is the most highest priority, then the explanation of why has to be in terms of what's changed in the sampled environment that produces the reward that adjusts the return used to calculate how the policy is adjusted. Now, finally, lastly, on the deep learning-based models, and this creates all kinds of potential confusion I'll try to redress in a few minutes before I end. If we use a loss function adjustment based on backpropagation, we're not guaranteed to get an answer. We may still get, after backpropagation adjusts the weights of the final neural networks producing the output, we may still get a prediction that Tweety flies. Therein lies the if you like, the unsoundness of backpropagation. Backpropagation hopes to improve the quality of predictions. But notice that backpropagation isn't used as a debugging method in the transformer-based deep neural networks. Why is that? Well, as a computer scientist, one can already understand that backpropagation through a 3 billion component network is going to be even more horribly inefficient than creating the outputs in the first place. And so backpropagation isn't used, as far as I know, in any of those representations because they would be prohibitively expensive. So what kinds of correction methods are used? As I said, maybe reinforcement learning with human factors. That spectrum of the problem, the way I've characterized it at each level of detail, starting with thinking fast, thinking slow, starting with these 4 samples of foundation models along the way, and with the application of this query update explanation paradigm, is really the substance of preparing Randy to be able to address the issue of how do you combine models to be able to get higher value than just picking any one of them. And so that's really the bottom line. So now, here is the speculation on what we can do with these foundation models. And this is where I invite you, given who I've seen in the audience and what I know about some of the backgrounds that you have, invite you to start to speculate with me on how we can put these together. What I would like to be able to do and what I speculate on is that the real foundations of computational intelligence will require at least some of the components along that spectrum integrated in some way that I simply don't know how to do well yet. We know at one end of the spectrum, we can use theorem provers to prove the correctness of integrated circuit design. At the other end, we know that we can use LLMs to produce a summary of my talk and a visualization in terms of a word cloud. But somewhere along the way, when we exercise the query update explanation paradigm, we will always want deeper, more accurate updates and explanations. For example, in the applications that I work on in clinical medicine, approximation isn't useful. Explanations are required to build trust in the value of the summaries produced when you use, for example, AI methods on imaging and on understanding natural language. So this is the role of explainable AI. Oh, and there's a note to self, insert one of my PhD students example-based XAI, explainable AI. But there's the problem. The foundation models in explainable AI is we need to be able to produce explanations of all foundation models, and they all look like black boxes to some degree, including the ones on the far end left of the spectrum, where it's not always obvious to a human about how to interpret the complexity of a 50-line proof that shows your integrated circuit component is correct. So along this spectrum, here's the speculation, is maybe what we want to do is we want to say that in this spectrum, we want to build a mechanism that uses this stackable neurosymbolic framework. That's going to mean we have to decide in any application vertical, any narrow area, we have to decide which parts require which components from this speculated 4-component stack. And so you can imagine that already. I would like to be able to do clinical diagnoses based on the knowledge I have of biology. I would like to be able to integrate historical evidence clinically to be able to make predictions and bias probabilities of a certain clinical study on the use of a drug. I may want to be able to exploit reinforcement learning to be able to produce rewards and returns based on observable changes in symptoms, for example. And at the very bottom of this stack that I've created, it may be the case that I just want to use things at the right end or now at the bottom end of that spectrum to be able to summarize the last 10,000 papers published on Parkinson's disease to look for evidence as in so-called literature-based discovery that Doug Swanson did several years ago, to be able to get a direction to be able to plan my next clinical study, for example. That's just Randy speculating how to stack these. So that's one way to think about it. The caution, and I haven't spent a lot of time doing this in some versions of this talk, the caution is that you can look at each of those foundation models in the following ways, is the logical foundation models include facts and inference rules. And Gödel and Turing, the American algebraist Emil Post, Markov, certainly with Markov decision processes, and others have talked about the challenges of how to represent the inference rules that capture the facts and allow us to draw conclusions. Similarly with Bayes rules, rewards and returns and action policies, and then weighted dependencies in this way. The reason that I draw that slightly more elaborate structure on the right is computer scientists, we know that this is where the Turing traps lie. Even with the 6 or 7 axioms of piano arithmetic, we know that we can quickly create systems that are either inconsistent or incomplete. And that's true for the logic models, for the probability models, for the return reward reinforcement learning models, and even for the transformer-based neural networks, encoders and decoders. And so that's one thing to be cautious of. There's a whole other summary talk that I could give on that. Each of those you can describe this way, and we can elaborate, but it's not timely now, is that you have a representation of the world and you have a self-representation. It's the self-representation that creates the problem. If you're ever written a computer program and used the symbolic debugger, the symbolic debugger is some kind of self-representation of the programming language in which you wrote the computer program. And the Turing completeness means that the symbolic debugger may itself be incapable of finding all of the errors because of the halting problem. And so there's where the caution arises historically. That these days, unfortunately, not many people are paying attention to. It nonetheless remains important. I'm thinking of, in my head right now, of a graduate student who recently said, "Oh, I don't refer to papers published before 2021 because they're too old." I can imagine Gödel turning in his grave. Now, the difference between what I wrote as a stack might be interpreted in this way. You might have those 4 models like that, and they might be in a community of agents. So, for example, we might have each of those foundation models collaborating together when one says, I can prove that there is a sequence of sound inference rules from your query to my answer, as opposed to the LLM saying, well, I don't know, the Springside Theater combines are what you do in the fall when you try to collaborate to haul in all the grain and do the work there. Maybe there are agents that interact to be able to do that. And so the last thing I want to say is what I've been speculating on, which gets us all the way back to the beginning of the human in the loop. And that is the notion of agents and societies of agents, which we hear a lot about these days. But I tried to look at the history of that to inform myself about how I should think about this and whether it has anything to say about my challenge problem of debugging a spectrum of foundation models. And here's some of the things that I found in the last couple of months. This is one from a small company starting in Japan called AI Gentic. Agent society, it's not a model, not a platform, a living decentralized network of autonomous AI agents that think, learn, and evolve forever. So continuous learning, the Q paradigm of query, update, and explain, although it's not implicit, although it's implicit here. There's one idea. There's more about this. Here is something that says the limitations that you can see, traditional LLM stack, like the one I drew. So I didn't write this table, but there's this notion of the traditional stack and this of the agent society. So the clear message here is that maybe there is no such thing as artificial general intelligence. Maybe instead all there are collaborating agents, and the agents work in an economy where their values and how they're valued and their value to other agents depends on what they do better than other agents. 2 people I'll note next have said something about having a agent economy by noting that the way the world works is that humans work and make progress by collaborating, not by bombing the hell out of each other, but by collaborating to solve problems that they independently cannot solve on their own. These are just some random backgrounds, but they refer to this background in the same way that I think about it. And let me show you where I think this comes from. Is you will recall a book called The Society of Mind from Marvin Minsky. And the most important thing about the Society of Tiny Components are that a unified theory emerges because together they can do things that they cannot do independently. In one of our robotics labs, one of the PhD students built a set of 10 robots. And the 10 robots' task was to move, to find and identify a box with a light on it. And each of the robots was a bit like a modern Roomba. They weren't powerful enough to move the box, but if they collaborated, 10 of them together could move the box exactly in this Minsky sense. Now here, that's the thing I should have put at the beginning to give you that update. But he said this a long time ago in Society of Mind. And now people are reinventing it, but they're actually not paying attention to where it came from, which is a bit sad. I knew Marvin very well, and he was a smart guy and a good mind, but he had very little patience for bad scholarship in science. Here's a more recent version. Is if you want to look, you can look at the URLs. I'll share these slides with Gary so he can just distribute them if you want to look at them. So Bill Roscoe has recently retired from Oxford, but he proposes this idea of a digital civilization where those agents work together in the way that Minsky described. So now you can imagine taking the foundation models all the way across those four in the spectrum I've speculated on. That doesn't mean therefore, it doesn't mean it have to be discrete, but taking those and putting them in this so-called digital civilization. And in fact, you can make this even more precise if you think about the optimization environment that Michael Jordan has speculated on, that is markets and machines, where those machines participate in an economic market and their value to each other is determined by somehow creating a currency of value that they all share. And I think that that's another interesting speculation that will help provide a framework to help solve Randy's problem about how one pursues the integration of those foundation models. Oh, am I going backwards? Oh, I see what happened is that I had changed the order of the slides. So let me summarize because I know that it's your lunchtime coming up. As I said to Gary at the beginning, is that this method of presenting things is often one way, so sorry for that. So here's the summary of the message is the first and maybe the most important part. This is a cartoon from Sidney Harris that I actually communicated with him and asked him for permission to use his cartoons, which he graciously provided. I don't think we're anywhere close to solving the problem of scientific challenges of AI. And if you listen to Sam Altman and Elon Musk and Dario Amodeo and others who think that the foundation models are all based on transformer-based deep neural networks, then you're being sold a bill of goods. But it is the case that there are multiple kinds of foundation models. They're going to have to somehow be blended to be able to achieve the next wave of progress in the science of AI. My own background that's patently obvious from how I've spoken about what I've observed is obviously in the neurosymbolic spectrum, starting from the left, moving towards the right. And that Q paradigm is useful because queries, updates, and explanations work for all forms of foundation model. No one of them is adequate. And then there's the more cynical summary, also from Sidney Harris. And this is maybe more appropriate for the background on Leibniz, Boole, Gödel, and so on. I work with logic, therefore I am. So that's the end of the talk, and I'll leave it to Gary to say whether you want me to say briefly something about open mind or see if people have some questions or updates or explanations for me.
Well, I'll be selfish and say I would love to hear a few words about open mind, and hopefully people can stay a little bit past one this time and
Okay.
have a later lunch,
Okay.
just to hear a little bit more about that.
And as I said, I will share these slides with Gary. The only important thing about the slides, by the way, is that there's never anything in the slides that doesn't have a URL that says where things come from. That's important for me as a scholar because I don't like, I like to speculate as a scientist to guide what I think about next, but I do not like to make up representations and make up references. So let me say a little bit about open mind. I said briefly the history of the three Canadian federally funded AI institutes. Amy was the first, Vector and Mila in Montreal, largely helped established by Yashua Bengio, Jeff Hinton and colleagues in Vector in Toronto. These days, me and Rich Sutton mostly Amy in Alberta. What happened is that DeepMind wanted a connection, that is the original company that Demis Hassabis formed some years ago, wanted a connection with reinforcement learning and the foundational models at the left end of the spectrum. And the best place that he could find to do that was at Amy in Alberta. And so the DeepMind office that was opened in Edmonton quickly became the second largest DeepMind office after London. When Google bought DeepMind, it closed down the DeepMind Alberta offices. We all speculate they were closed. The announcement to close it was made on a Friday. We had 5 of our Amy faculty seconded to DeepMind, working in the DeepMind offices in Edmonton. When it was closed, the bottom line is that those of us with experience observed it was closed because Google's strategic agenda overall was changing. And so Google's DeepMind working on reinforcement and continual learning seemed not to be central to Google's falling behind OpenAI on the LLM thing. So what Rich and I decided with one of his former postdocs, Joseph Modial, decided we would start a new company and raise money for this company called OpenMind. It started in Canada with the first one as a not-for-profit in Canada. We raised enough money to hire 4 initial fellows and build the infrastructure. The most important part of this is that we followed a long laid out agenda called the Alberta Plan, which was a 12-component plan for about 10 years of AI research based on partly reinforcement learning, focused on continual learning and continual updates, not batch learning. And the logo we see is as you see there. The mission is easy to say: understand intelligence and share it openly with the world. Because of our experience with DeepMind, the buy-in and the fellows that we hire for OpenMind's research agenda join with the commitment that all of the research that's created, all of the software that may emerge, and all of the publications are all open sourced. Everybody can use them. There is nothing to prevent anyone from using them. And so that's the basis of OpenMind. OpenMind then said we can't be only in Canada. We have to be worldwide. And the first thing we did was survey where in the world we could build OpenMind Global as the figurehead, the umbrella of having OpenMind labs around the world. The best place to do that, we found, was Singapore. So we incorporated OpenMind Global in Singapore recently. It was incorporated just after Christmas of last year. And we're raising money there because it's easier to raise money outside of North America and not get into geopolitical conflict. So we can raise money from Asia, from Southeast Asia, from depending on the time of day, I guess, and the situation with the current war going on in the Middle East. We can raise money from the Gulf states, from Asia, from Southeast Asia, yes, from the United States and Canada, but that's why we started OpenMind Global. And that's the summary of what we're doing there. Each of the OpenMind labs, the one run out of Edmonton is a virtual lab. OpenMind Global is now the parent corporation. OpenMind Southeast Asia will have commitments to start that within the next month or 2. And all of the work will be interaction with locally established connections. The AI Singapore is a partner, AI Malaysia is a partner, AI Pakistan is a partner, AI Vietnam is a partner, AI Indonesia is a partner, organizations in China, not-for-profit organizations, robotics companies, Tencent, ByteDance, all kinds of companies like that. So that's what we're doing there. Oh, I see a hand.
Actually, let me kick this off. I had a comment sort of with a question.
Yep.
If I look at your diagram going from left to right, we
Yep.
have symbolic on the left, and we have you have Gen AI, large
Yep.
language models on the right.
Yep.
And together, those sort of are what we've talked about often as hybrid systems. And our next speaker next week,
Yep.
Pascal Hitzler, will probably say a lot more about that. I'm just wondering if you're aware of other hybrids which incorporate some of these other foundational models as part of their work, so that we can broaden the idea of hybrids themselves.
All of the things that I am aware of are largely driven by engineered improvements to the right end of the spectrum with respect to LLMs. Like I said about the so-called preoccupation with what's called reinforcement learning from human factors. I'm not aware of anyone who has started by saying, I'm going to build a logic-based reinforcement learning foundation model. That doesn't mean they don't exist. It just means that I'm not aware of any. I think it would be a good thing to do, but the caution is that we know that building things at the right end of the spectrum with mass volumes of data consumed in a panda-like way is expensive. And so when you think about engineering experiments for the combinations of logic and probability models, one probably has to be cautious. I'll give you another example because it's a good question. Example is how we apply the query update explanation paradigm in automated driving. So in automated driving, we've built this explanation facility that explains to the passenger of an automated vehicle how an automated vehicle made a decision. So you can use anything you want to build the policies. You can use reinforcement learning to learn driving policy. And then if the passenger in the car says, why did you turn left? You immediately have two kinds of problems. One is the knowledge problem of what knowledge was used to make that decision. The other is the timing problem. That is, you need to be able to be efficient enough in calculating explanations so that the passenger gets an explanation in a timely way. So if you say, why did you turn left? And it takes 4 hours of computation to say, oh, you'll notice in the video that a soccer ball got kicked out into the street. And so I stopped and turned left here to avoid hitting whatever was chasing the soccer ball. The 4 hours later explanation isn't sufficient. So you get the idea, right? But
Yeah.
the point I'm making is that the engineering of those specific narrow applications has to be done, especially in a publicly funded academic environment, has to be done very carefully because we can't just take the open source code for Meta's Llama and then reprogram it and hope we can run to be able to produce those verticals to demonstrate the value of the combined foundation models. I don't
Of
know
course, we get thinking fast explanations as well as thinking slow explanations from humans too.
Yes,
Yes.
absolutely.
We have two hands up at least, Ram and then John Sower. And I know Ravi had a lot of comments in the chat, so maybe that progression from Ram to John to Ravi. Please let us know what time you have available, Randy, okay?
Well, I'm good as I'm good for till 11:30 that I had planned on. So
Okay. All right, Ram.
Oh, okay, Randy, thank you for that excellent talk. Actually, if you put the couple of questions that I have in terms of your spectrum that you just showed, logic at one end of the spectrum and neural networks at the other end of the spectrum.
Yep.
Now, those two ends of the spectrum, whatever it is called, what actually is the purpose of that, having that logic? The question I have is that instead of having logic and neural networks, maybe there's something else at that spectrum, ends of the spectrum, because one is that complete knowledge versus incomplete knowledge, something like that. Okay, like if you're talking about a logic-based system, you have an old model and you have a lot of symbolic type of structures around there, and you go to the other end of the spectrum, it's basically I don't know what it is. Okay, some neurons connected, some weights, and so on and so forth, and they're being manipulated. So, are there any other ways to characterize the spectrum? Just not only logic and neural networks, but some other terms which reflect logic and neural networks. That's one of them.
I think it's a fundamental question you've asked it. Let me tell you how I've been guided to think about it by all of the people I've interacted with. One of the things that I've found that helps address the question you're asking is where each of the inference styles along the models that in that spectrum that I've identified, where each of the inference styles might combine to help solve a problem. And I'll give you one example. One example that I've recently come across is working with when you get down to this level of physics, when you're talking about materials and material physics, I'm reluctant to talk about whether someone is a physicist, a chemist, or a biologist, because when you get down to the nitty-gritty of molecular structure, it matters less what your discipline is labeled to be. But at that level of detail, one of the things that emerges in medicine and in material science is the search for where to look for materials with the properties that you need. So when you're designing materials that have to have certain magnetic moments in material science, when you're searching for configurations of complex proteins to be able to be the basis for docking to cancer cells, to be able to provide the basis for the design of drugs. Both of those situations, that I've come across, can use the full spectrum that I've spoken about in the foundation models. On the right-hand side, you can use LLMs to read 10,000 papers on systems biology and say, what are the dominant themes in looking for new characterizations of proteins for this particular kind of cancer cell? They won't deliver the systems biology knowledge that says, here's the exact configuration of a protein, and here's the exact physics, the biophysics of the docking for that molecule on that particular cancer cell, for example. But what they will do is guide your search through the other end of the foundational spectrum to say, can you produce, for example, a sound logical argument that says, here's how the physics of proteins confirms why this particular configuration of protein actually docks with this particular protein in this cancer cell. And so that's an example. It happens in the material science as well, and in organic chemistry, is that you use the right end of the spectrum to speculate on where to look, to reduce the number of options you look at, and then you use the left end of the spectrum to confirm this. In the Virology Institute at University of Alberta, we have one of the most recent Nobel Prizes in virology, a guy named Mike Houghton. What they did is they used some big pieces of machinery to search for configurations of proteins for certain viral models, in this case, in liver diseases, for example. And they reduced the search through 13 billion alternatives to something like 30 alternatives by using their knowledge of virology based on summary knowledge of the 10,000 papers I use as euphemism for compressing knowledge. So I think that that's a very complicated answer, but the question you asked is fundamental. It's how can you
Thank you. And also,
the
but
values?
another thing, Randy, you used the
Yeah.
word foundation model in there.
Yeah.
Now, the foundation model, for example, in LLMs, it requires training them with these large amounts of knowledge out there. For
Yeah.
the logic models, when you talk about the foundation model, how much amount of knowledge we have, there's a lot of things that we need to train. People are talking about building these huge knowledge networks. In fact, I put it on the chat, today's news, day before yesterday's news, about this thing which Lacoon is talking about, raising $1.03 billion to build old models. Now,
Yes.
does that fit into this logic model foundation kind of thing? And after that, I also have a quick comment. This AGI business, people talk about artificial general intelligence. I think they're barking up the wrong tree to
I
talk
agree
about
completely.
AGI. So
I
that's all.
agree completely. So back to I'm looking forward to just finishing this part and getting to John Sawa's comment, because he and I have a long history, and I would speculate that he and I both have some tasks to take up with Jan LeCun. So when Jan LeCun said he was leaving Meta to start a company because world models were important, I said, amazing. He's figured out something that John and I have known for 50 years.
Right.
It's,
And yeah, I would, in fact,
to
I would
your
like,
point is building models of the world has always been really hard, right? That's why it's the verticals and the expertise that the vertical humans have to characterize sufficiently knowledge that can be used in the left side of that paradigm to be able to, for example, create a cogent argument that this configuration of proteins at this level has a higher chance and probability of being the right binder to that molecule. So wonderful to raise money to build world models. We've been trying to build world models ever since the days of expert systems and found out that the bottom line is that it's expensive. Expert knowledge is not easy to accrue. Characterizing it in a way that machines can help us use it is even more difficult. So kudos to LeCun for using his notoriety to say world models are important. Many of us, except probably many of us on this call, anybody who would have the invest the time to invest in this kind of collaboration discussion, right? Already believes that, as far as I know. It's just a really hard problem. And I think that you're right about what you said about AGI in the same thing as things I've hinted at before, is there is no AGI.
Mhm.
There are systems, when we understand how intelligence works, we can help build systems that accrue knowledge across that spectrum. It's knowledge and it happens to be on the left side of my spectrum, or it might be at the top of someone else's spectrum, however they draw it, but we need to combine them. Logical knowledge has always been easy to explain and hard to update.
Mhm.
On the other end of the spectrum, you can easily update an LLM by providing more inputs, but the tokenization at that level still makes them the pandas of the foundation world, right? Is that they're taking tokens, recording statistical relationships between, say, 3 billion of them, and then generating the most statistically coherent output, which turns out to be really useful.
Mhm. Thank you very much.
No, thanks. That's a good fundamental question.
okay. I'd like
John, you're up.
Yeah, the point I'd like to emphasize are that some of these foundational models last for years, multiple years, 50 years, 60 years. And
Yeah.
a prime example is the airline reservation system. IBM developed this for the 7090 back in the early 1960s.
Yep.
They updated it for the System 360 and 370, and it has been used for everything. They started with reservation for airlines, but then,
Yep.
of course, they needed to have rental cars, so they added rental cars. And
Yep.
then, of course, people go to hotels, so they have to reserve hotels. And then they have to go from hotels to taxis. So they ended up being a system that the foundation, the logical foundation, has remained constant for
Yep.
over 60 years.
Yep.
And it's used for reserving everything. It started with IBM, but every company that had to interface with it had adopted the same system. So every company, every little company, everybody who's making a reservation for a hotel room is using the same paradigm, the same structures, and they're all there. And so that's what I want to emphasize, that the logic, the fact that you're using symbolic logic is irrelevant. The fact is that the structure is so firm and precise that logic is obvious, and the logic and the computers go together hand in hand, and it's all there.
I think that's a great point. Absolutely great point, because the you, like I, get weary of the reinvention of ideas, thinking that they're new. The reality is that for those systems that continually provide those quote foundational aspects of the question, update, explanation, are great examples of where we should focus. And it's the query, update, explanation, whatever you want to call it as a paradigm, that stabilizes it and makes it has that long value. So I agree completely. How to engineer, remember that so I'm a public scientist. how to engineer the results of what we discover in our experiments as public scientists means maybe we can re-engineer those things to have a longer life. I'm not sure.
Even one more point is that the airline reservation system actually didn't start from nothing. It started with a project that IBM had for the Strategic Air Command,
Yep.
and representing, modeling all of the aircraft flying across North America, and summarizing them and analyzing them. And so it went back even another 10 years before that.
Yep.
And so it's basically 70 years of the
Yep.
same fundamental model. The structural model is the foundation, and everything has been built around it.
Yep, and the structural model that emerged from that, for example, at Stanford Research Institute, when it was still called that before it changed to SRI, for agent, the so-called belief, desires, and intention agent model was used to model military aircraft surveillance in Australia, for example, with contractors from SRI, and that was based on the history that you just spoke about. So you're right; they've existed for a long time. Back to Ram's question, the question is, are we learning anything new from the science of foundation models that allows us to understand how to improve the engineering of those systems you just mentioned? From the software engineering point of view, sometimes we always ask the question of academic software engineers is do you have any greenfield development? Do you get to start afresh, or must you live in a world which already has momentum, and that your job is to understand what the current state of the world is and improve it? There's been a lot of online stuff in the last 2 weeks about assessments of the failure of automatic coding using LLMs, because the code they create proves to be undebuggable should there be errors in it. And so they're actually slowing down software development by building things that are hard to maintain.
Right. You need that structure. And
Yep.
that structure is logic. So
Yep.
even though logic, you don't have to represent logic in a formal logic form.
Exactly.
Every digital computer is based on logic, and everything there is strictly zeros and ones.
Yep. There's another thing that happens. So, John, you probably know, let me see. Joseph Safakis is another Turing Award winner that I had some interaction with, who spent a lot of time building theorem provers to help produce correctness results of mission critical software. And in discussions I had with him at a workshop in Hong Kong just before Christmas, it was interesting because the discussion broached what you just said, and that is that we know the sense in which what logics are powerful enough to be Turing complete, and we know how to build computers based on some of those principles. We know the extent to which probability and Bayes rule is complete with respect to calculating predictions based on priors is complete. There are even recent proofs that transformer models are Turing complete, by one of my colleagues at Google Brain DeepMind, Dale Sherman's. So we know that those are Turing complete. We know that Prolog is Turing complete. There are a lot of answers to whether the computability is there. The real question is what John said, is how do we organize the architecture to be of value? So the halting problem applies to all of those models of Turing completeness. We can't get around it, right? Gödel will always be right. But how do we get value out of these things by being wary of, for example, how they can be updated and debugged? That's the thing that I try to focus my own thinking on.
Okay, we have time for Robbie, who had many things in the chat, and if there is time after that, I wonder if Michael Gruninger, still on here, has any comments that we can also include. So Ravi, you first.
Yeah, I would like to request Mike to speak first.
Yeah, I don't know if he had a comment, but I always enjoy the possibility.
Yeah, so Randy, I mean, I really like the talk and the kind of approach that's being taken, and I really like the focus on the debugging kind of aspect. But yeah, to what extent, like when you have a theorem prover, you can take a look at the proof, you can inspect the proof, and
Yep.
kind of convince yourself everything works. But when you have a LLM sort of generate an explanation in a way that's not an insight into what it did,
Yep.
it's just another, the prompt was explain your answer. So really,
Yes.
it's not an explanation; it's a response to another prompt.
Yes.
So to what extent can you actually? Is it a well-posed question to say that you can debug an LLM?
I think that's a good question to ask, Mike. And let me give you some idea about how my interactions with people have exposed that. It's another parts of these talks I have diagrams, not surprisingly, diagrams that, for example, at Google, when the Google engineers trying to debug Gemini, or trying to improve Gemini's output, said that the only way they can do this is by identifying exactly what you said, by identifying which portions of a 3 billion parameter space are actually used to inform the generation of the next token in the output, right?
Mm-hmm.
Yeah, exactly as you summarized. And so part of what it looks like in that case is the Google engineers in one of their papers explicitly said, we can't possibly debug any of this, or we can't find the errors if we can't localize the computation. That is, if we can't visualize where in the 3 billion parameter space where the components were used to be able to generate the next token, right? Because that's the context problem, like you said, and I think Ravi had said something about that in the chat as well, the context. So the duality of the context is a bug, or the bug is the consequence of the context. So the answer that I speculate on is that the best we can do, remember that this is a question about human bandwidth, right? It comes back to what humans can do. So that's why I've started reverting to showing word cloud visualizations of documents, saying that's as a caricature of what the LLMs do. And one of the things that people have done a lot of is invent this thing they call chain of thought, right? So everybody's come across that word, that phrase, chain of thought. Never clear what it is. If I put two people who use the phrase in a room and ask for explanations, I get at least two different explanations what it is. But you and I know what it is because of our heritage. We know that, back to your premise at the beginning, that you can follow even a complex proof and be confident if sound rules of inference are used. So now in that context, I think you're right. That's a fundamental challenge about what is it that we are doing when we entertain the idea of debugging the large language models. And I think Ravi's question is probably right. Let me give you an example based on the earlier examples I had. I talked to a guy from Sony AI Research at a workshop in Kuala Lumpur in November. I think November. Oh, no, sorry. It was January this year. Sorry. I lose track of time now. And he took the query that I used for Gemini for the Springside Theater Combines. He typed it into Cloud, but he added in the prompt a phrase. And it's related to what Ravi said about context and bugs. Is the phrase he typed in beside what are the Springside Theater Combines? And the phrase right after was, don't make things up.
Oh,
And what came back was an answer that says, oh, the Springside Theater Combines could be referring to the combination of combines ganging up to do the harvesting, or it could be a baseball team in southern Saskatchewan. Now, there's an answer that's related to Ravi's question, right? Is that the identification of the context used to create the output is really what debugging comes down to, right? And that's what I think, in principle, is the answer to your question, is that at that far right end of the spectrum, there isn't debugging in the conventional sense. It's too
Mhm.
hard.
Mm.
But there can be the contextual awareness to say, I've produced the output to this question on this level of computation invested to do the inference in the 3 billion parameter model. That may provide a basis for this speculative thing called chain of thought that everybody gets excited about, because as humans, we all like to think
Mhm.
that there's a rationalization for the output that comes out, right?
Yeah, yeah, yeah.
That's why your question is so important. And Ravi, thanks for even in just what you typed, that context determines whether the bug is, and the shift of context changes that. We know that from ordinary logic programming. So, 30 years ago, David Poole and I built these diagnosis systems. And if you know that a cold causes a fever, and you know that influenza causes a fever, and you observe someone has a fever, you can correctly, soundly predict a cold because of that knowledge. You can simultaneously correctly predict a flu because that also causes a fever, and they're not compatible, but they're consistent, and the context determines that one says, well, here's a speculation. We've speculated hypothetically that you have a cold because you have a fever, or we can speculate consistently that you have the flu because you have a fever. Further context will reveal which of those is correct, like another diagnostic test.
Cool, thanks.
Wonderful.
Maybe we have time for Ravi's comments
Just
and
a,
questions.
just a two chain of thoughts I want to leave for the audience, and certainly enjoyed tremendous interaction among Randy's talk, Ram Sri Ram, and Michael, and certainly our leader, John Sova. So my question is on two fronts. One is obviously the topic which is going on, namely context, explanations, understanding, and the results or actions. That's a wonderful and prerequisite for any knowledge to give meaningful output. The second question is, how do we learn in machine sense from analogy of human learning, classroom learning,
Yep.
collaboration
Yep.
for projects like Apollo on which I worked,
Yep.
and then other things of learning is like Upanishads,
Yep.
namely teacher and the student
Yep.
sitting in front of each other and conversing. So which of these models will apply to machines beyond these connectors and things that we use in neurosymbolic?
I think what you've just said is part of the solution to the problem. So remember that the so-called knowledge acquisition bottleneck of the expert systems of the 80s and to some degree the 90s was the cost of capturing expert knowledge. Expert knowledge was not necessarily always correct, right? So as a physics student, you learn enough about physics to know the distinction that force equals mass times acceleration, unless you get close to the speed of light, and then things change, right? So you learn that, and then your knowledge about where you're working accrues, and you can capture it, and maybe you can convey it to a machine by a kind of programming that's accelerated by some kind of machine learning. Inductive logic programming was an example of how to take statements that humans could understand and build theories that could be useful in doing that. But the fundamental problem is, I think, is the explanation part, because that's intimately connected to debugging, like the framework that Michael anticipated when he asked his question, and that you actually gave me there's a wonderful gift in your statement, because now I can't stop thinking about whether a bug is the same as a good solution depending on the context. And I think that that's another part of it that we will always have to address. we will always be in the situation where output from any mechanical system, think about all of the things that we could ever possibly compute, we'll always be in the situation of wanting to confirm why what we receive as output, how that can be verified to any degree according to what we have to use it for. So, for example, a physician needs a sufficient explanation when he's prescribing an intervention in inflammatory bowel disease from the text of the radiologist looking at images and the text of the clinical physician looking at the current status of the metabolism of a patient, for example. They'll always need that. I don't see any way around that. So that means the idea of, as I think it was, Ram, the idea of artificial general intelligence seems silly. AGI, ANI, I like Gary Marcus's version as BSI, as he says, broad, shallow intelligence. But remember, I came from the prairies of Canada, so BS means typically something different in the closest first approximation.
To end up, I was thinking when you presented your stack, that sort of maybe this action policy was the most general thing, because humans have to learn all of these types of knowledge in a sense, or their equivalent. But then, so I guess it's an experience model via learning, a learning experience model, how to build each of these foundations might be really an interesting way of proceeding.
Yep. That's now everybody should be completely comfortable with the reason I put partial in the title in parentheses, because if I knew how to do this, maybe I would be the CEO of $1 billion unicorn. But actually I wouldn't be, because as long as I've survived, the basic premise says the science of intelligence is pursued in its own regard. I don't want to duplicate humans, but I do want to be able to build things that humans can use to be able to accelerate what we do well and amplify what we do well.
I have one comment in that regard, that if we all keep open license for everything we do, as you advocate, and I agree.
Yep.
How do we control misuse of what we openly convey? So it's always been that way, that technology developed for one purpose is used for another purpose. And how do we make sure as a society to control misuse of that?
Well, it's a question that I think we will continually struggle with, and certainly one that Rich Sutton and I struggled with to form Open Mind. And I don't know the answer to your question, but let me give you a contrast, because the contrast is in where the solution lies, I think. So at a recent, my colleague Yashua Bengio from Montreal has been very involved in his Law Zero company and in the European and United Nations guide rails and guidelines for AI. And there's a very telling debate. Remember that Law Zero gets a lot of its funding from Eric Schmidt, the former chair of Google and Alphabet. And the telling discussion that I think informs your question was between Yashua Bengio and a senior Chinese government official she was previously the minister of technology in China, and she was participating in this dialogue. And she was an advocate of open source. And in this thing that you can find online, you can find it in a YouTube clip, Yashua Bengio explicitly said he was against open source because open source would just accelerate the dual use of AI technologies. I think that is exactly the wrong thing to do. Is that the dual use of technology is a challenge that we've faced on planet Earth for humans since our existence, forever. And the challenge of dual use has nothing to do with technology. It has the challenge with societal norms, culture, and education, and what we make as priorities. So if your priorities are to do things for the human good, that's the only antidote to the dual use, negative use of things. You can't change that. Restricting things by not making them open source seems like exactly the opposite way to do that. I think that that's a very important aspect that you raise in that way, is that you start with the open principles, and hopefully you create generations of people who understand that open use means anybody can endeavor to try to add value with the technologies that are open in that way, as opposed to think that there's some power structure that will always do the right thing. We see where that's getting us these days.
Yeah. Yes, you still expect the professionals like a doctor in the ER to use AI, but not be led totally by it.
Absolutely. There's a
Yet.
great quote from the last thing to leave you with, maybe, Gary, is a great aphorism quote from the Canadian Medical Association. Just after COVID, I did a countrywide assessment with interviews of AI experts, quote, experts doing work in medicine. And the aphorism that comes out really aligns with what Ravi said. It said this. So the Canadian Medical Association said, in the near future, physicians will not be replaced by AI. But in the near future, physicians who don't use AI will be replaced.
Well, on behalf of everybody, Randy, and there's applause going on, I want to thank you for this wonderful talk. You've been just super generous with everything, and we really appreciate that. I am already looking forward to inviting you back next year to get an update on this, because things are moving rapidly.
They are moving rapidly. Thanks for
whatever our topic is.
Organizing this, and it's nice to see old friends. I don't remember the last time I saw Michael, and I don't remember the last time I heard you talk about something, John. So it's nice to make those connections.
And I hope, Randy, you would kindly look at the chat for comments from Janet, Todd, and others.
Okay.
I saved the chat, so Ken will probably be able to put them on the site. He's probably saved them also. And I'll just say, we have Pascal Hislett talking next week, and perhaps he'll have some follow-up topic comments. He's going to be talking about hybrid or neurosymbolic hybrid. So I look forward to that too. Again, thank you again, Randy. It's been wonderful.
Thanks for all of the comments. Your comments and questions are what shape how I think about things. So I'm indebted to you for investing your time and energy and experience and knowledge.
Thank you.
Thanks. Bye.
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 Thanks to everyone.
So with that, we will adjourn and hope to see all of you next